All right, well, good morning, ladies and gentlemen, or good evening, afternoon, whatever it might be. Today we're going to start talking about hyperbolas. This is the next part of the conic stuff that we're going to be looking at. And same things go. We have A's, B's, and C's. Let me just show you what the equation looks like. Today we'll start with everything centered at the origin. So equations for the conic sections of a hyperbola is x squared over a squared minus y squared over b squared is 1. And y squared over a squared minus x squared over b squared is 1. Now, what makes the hyperbola formulas a little bit different than the ellipse ones that we just got done talking about is notice that the a squared is always first in both equations. It does not matter which one's larger, okay? A squared is just the first one that's written out. Notice what changes. The x squared changes place with the y squared in the two formulas. So to be able to tell what direction this goes depends on which one comes first. In this case, if the x squared comes first, we know that the shape is going to look like this. If the y squared comes first, it'll look like this. All right. Now, A is still going to be the distance from the center to your vertex. B is the center to what's called I'm going to put it in parentheses, covertex, because it's not technically a covertex. We use it to help graph. And then C is still the center to the focus. Now, just like in parabolas, ellipses, we were able to find the c squared term. We do the same thing with hyperbolas, but c squared is now found by a squared plus b squared. Now, it'd be really easy to tell which one you have to use when you're dealing with finding C. It's always going to be the opposite of whatever the sign is here. In ellipses, remember it was plus between the two, so it was minus here. And now this tells us that when you think about the graph, if the center of the hyperbola is here, the focus is going to be further away than the vertex. As we get in here and draw a few of these out, you'll see what's going on. So let's just jump right in and look at an example. Let's see here. Let's say we have 4x squared minus 9y squared is 36. So right off the bat, you'll notice that the x squared term comes first, which means this one has to go left and right. So what we do is we have to first then get the side equal to 1, so we divide everything by 36. And you wind up with x squared over 9 minus y squared over 4 is 1. Okay? Now, just like before, we list out everything. We know a squared, the first value, is 9. Therefore, a is plus or minus 3. The b squared value is 4, so b is plus or minus 2. C squared is found by a squared plus b squared, so we get 13, so C would be plus or minus the square root of 13. Okay. All this will come into play here in a second as we start to rough sketch. Now, remember, everything today is centered at the origin, so we draw it out. So our center is at 0, 0. Remember how we always like to make our lists. We know this has to go left and right, so A value tells you to go left and right 3 to find your vertex. So my vertices are at 3, 0 and negative 3, 0. Covertices is our B value, plus or minus 2. 0, 2, 0, negative 2. Now, here's where hyperbolas get a little funky. What happens now is that we can't do anything else until we draw in this imaginary rectangle that this space creates. Notice, all I did, I went to the vertex, I moved up to where the line of the covertex would be, and I went back around and just created a rectangle. What happens with hyperbolas will have asymptotes. these asymptotes allow you to figure out how wide your curves are being created. Okay? So we know that it's got to open up left and right, so it's going to be making a hook here and here. Last thing we have to do is plot out our square root of 13 for our focus. Now, remember, square root of 13 is less than the square root of 16, but it's more than the square root of 9, which means it's got to be somewhere between 3 and 4. So all I have to do is just mark out a 4 on both sides and just put a dot. So we know our foci are at square root of 13, comma 0, and negative root 13, comma 0. So we do this. We hug the asymptote, go through the vertex, and hug the asymptote. Same thing on both sides. All right. Last thing, we're always going to find the equations of our asymptotes. All right. Now notice I'm going through the origin. So think of this as a y equals mx plus b. Well, our b value is always going to be 0 because that's your y-intercept. So all we have to do is find out our slopes. Well, our slopes are up and over. I went up 2 over 3. So it's positive 2/3 x. And then the other way, I went down 2 over 3 to get the other side. So your two equations, when we're centered at the origin, this is a nice shortcut, are just going to be plus or minus the slope of the asymptotes. So these are your equations of the asymptotes. Okay? It looks like there's a lot of work, but remember, all you're doing is you're working through your a squared, just like we did before. Remember, your c squared value is a little bit backwards. And then you just have to remember what direction these things are going to move. Once again, if you forget, you can always go to your apps button and just go to your conics. Now, we're talking about hyperbolas. And you'll see if the x squared comes first. I can do this without the... There, you can kind of see how it's drawn off to the side, and then the y value. Sorry, the glare is pretty bad with oh, there it is. So if you look at it that way, you can see how the x squared goes left and right, and y squared goes up and down. Okay? Let's try one more of these. And this time we'll do one with a y squared first, so you can see how this one is going to look. Okay, so let's start with y squared minus 16x squared is 64. So it's going to follow the rules. Y squared over a squared minus x squared over b squared is 1. Since our y value is first in this equation, we know that this has to move up and down. So first thing we do, divide out by the 64 and rewrite. So we have y squared over 64 minus x squared over 4 is 1. We know our center is at 0, 0. Our a squared is 64, so a is plus or minus 8. Our b squared is 4, so b is plus or minus 2. C squared is going to be 64 plus 4, which is 68. So our c value, remember the shortcut, the trick for doing square roots in this calculator, go to your, let me quit here, go to our y equals. If we take 68 divided by x squared and look at your table, I'm looking for where does it go to become all decimals in the y. So notice it's at 2 root 17. So this would simplify out to being, excuse me, plus or minus 2 root 17. Okay? So, start our plot. And center's at the origin. A value, we know it's got to go up and down, so it's got to go up and down 8. So our vertices are here, in here, so we write it down. Vertex are at 0, 8, and 0, negative 8. Swipe off the screen there. Co-vertices at b values, 1, 2, 1, 2. So our co-vertex, technically that's not there, but we still use it for graphing purposes, is at 2, 0, and negative 2, 0. Now we draw in our imaginary rectangular box so we know where our asymptotes are going to go. This might be a little bit difficult to draw on the screen with all the dots, but give it a shot. You should be okay. And zoom out a little bit here. Nope, I can't. Ooh. All right, well, anyway. So we'll draw up our asymptotes. Okay. Focus. The focus was at the square root of 68, which we simplified out to being 2 root 17. Now remember, the square root of 68 is just a little bit more than the square root of 64, so it's just a little bit beyond 8. So I just put a little dot here. Remember, it doesn't have to be absolutely perfect. You just know that the labeling it is more important. So we're at 0, 2 root 17, and 0, negative 2 root 17. And then all we have to do left is graph. Hug the asymptote, vertex, hug the asymptote, hug the asymptote, vertex, hug the asymptote. And that's what this stuff should look like. I know it's a little bit different, but couple trials of this stuff and you guys should be doing just fine. Tomorrow we'll do the idea of writing the equations given specific values, just like we did the other day, and then hopefully that would leave us for Thursday then to try to write some of the equations out with and work with the shift, and we'll go from there. So hope all is well, and we'll talk with you guys later.